Hello students, today we will do exercise 1.2 of chapter 1, that is real numbers. Now before the exercise, we will recall some of our previous knowledge about prime numbers and composite numbers. Now, what are prime numbers? Prime numbers are the numbers which are greater than 1 and has two factors, 1 and the number itself. Now I am taking some examples. 2 is a prime number. It has two factors, 1 and 2. Or you can say it is divisible by only two numbers, 1 and 2. Now similarly 7, it is divisible by 1 and 7, so it has two factors. And similarly 29 has two factors, 1 and 29. Now 2 is the smallest prime number and it is the only even prime number. Other even numbers are not prime. Similarly, composite numbers. Composite numbers are the numbers which has more than two factors. Composite number has more than two factors. Now, if you take some examples, 16, it is divisible by 1, 2, 4 and 16. So it has four factors. Similarly, 4 has three factors. 9 is also divisible by 1, 3 and 9. So it has three factors. So we can say that prime number are the numbers which has only two factors, 1 and the number itself, and composite number are the numbers which have more than two factors. Now 1, it has only one factor, that is 1. That means it neither follows the definition of prime number nor the definition of composite number. So 1 is neither a prime number nor a composite number. So you will never write 1 as prime or composite. It is ये ना तो prime number है ना ही composite number है. 1 ना तो prime होता है ना composite. Now see composite number 16. I have taken some composite number here. Now composite numbers can be written as the product of prime factors. Now 16 can be written as 2 into 2 into 2 into 2. We can take prime factors of it. 9 can be written as 3 into 3. Similarly 30 can be written 2 into 3 into 5. So we can say that prime numbers can be factorized or can be expressed in terms of product of primes. नाउ दिस फैक्टराइजेशन इज यूनिक. ये यूनिक होता है क्योंकि आप 9 के फैक्टर 3 इंटू 3 लिख सकते, कोई दूसरा नंबर नहीं लिख सकते आप. बट इरेस्पेक्टिव ऑफ द ऑर्डर इन विच दे ऑकर, इनका ऑर्डर देखो, यू कैन राइट 30 एज 2 इंटू 3 इंटू 5 और 3 इंटू 2 इंटू 5 और 5 इंटू 2 इंटू 3. यू कैन चेंज देयर ऑर्डर बट द नंबर्स, द प्राइम फैक्टर्स विल बी सेम. This is called fundamental theorem of arithmetic. Now, statement of fundamental theorem. Yeah, what does this definition tell you? That every composite number can be expressed as or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. So that means here we have also seen the factorization. Yeah, these prime composite numbers can represent at the product of the primes, and this factorization is unique for every number, and irrespective of the order in which they occur, their order can be changed, but the numbers will not change. Now, one more thing. Suppose I am taking two numbers, 8 and 26. Now 8 can be as a prime factor. It is a composite number. It can be written as the product of its prime numbers. So 2 into 2 into 2. Now 26 can be written as 2 into 13. If you take HCF and LCM of this one, so what is the HCF of 8 and 26? The common factor in these two is 2. Therefore, the HCF will be 2. HCF is the common factor of the numbers. Now LCM we will write all the factors of 8 and 26, and the common factor will come only once. Now 2 into 2 into 2 into 13 will be the LCM, because 2 is the common factor, it will come only once. So this is LCM of the numbers. So we are getting LCM as 2 into 2 into 2 into 13, that is 104. Now If we take product of HCF and LCM of 8 and 26, the product is 208. And if we take the product of the numbers for which we were taking LCM and HCF, this is all 8 and 26. This is also giving us 208. That means, what does this tell? That HCF and LCM of the numbers is equal to the product of the numbers. The both answers are 208. So for any two numbers, the product of HCF and LCM is always equal to the product of the numbers. But always keep in mind that this criteria follows for only two numbers. If you are taking LCM and HCF of three numbers, then this criteria will not follow. Now there is one question here. Before doing the exercise, we will take one example. Now here there is a question in your book that consider the number 4 raised to power n, where n is a natural number. Check whether there is any value of n for which 4 raised to power n ends with a digit 0. Now 4 raised to power ends with digit 0. That means for any natural number n, if we are taking natural number 1, 2, 3, so 4 raised to power 1 will give us 4, 4 raised to power 2 will give us 4 into 4, that is 16, 4 raised to power 3 will give us 4 into 4 into 4, that is 64. Now I am considering a number 230, it ends with 0. Now for a number to end with 0, it should be divisible by 10, or it will be multiple of 10. 10 into 23 will be 230. That means for any number to end with 0, it should be divisible by 10, or its one factor should be 10. Now see here, for any number, suppose I am taking 4. Now for the factors of 4 are 2 into 2. Now if I take square of 4, that is 16, then the factors will be 2, 2 is 4, 4 2 is 8, 8 2 is 16. Or you can say this 2 into 2, 2 into 2, there's two sets of 2 into 2. This will be 2 into 2 ka square. Similarly, if I take 4 cube, this will give us, similarly, this was 4 square, 2 into 2 ka square. So this will be 2 into 2 into, 2 into 2 cube. So whatever power we take of 4, it will always give us factor as 2 into 2. Now that means in 4 we are not getting 10. 10 means, now for 4 raised to power n to be divisible by 10 or to end with 0, we should get two factors, 2 and 5, two prime factor 2 and 5. If we get 2 and 5, then 2 5s are 10. That number will be divisible by 10. But here in case of 4, we are not getting any number, we are getting 2, but we are not getting 5. So whatever power of 4 we take, we will never get 5 as its prime factor. So how will you solve it? Now for this we will write a statement. Now if the number 4 raised to power n ends with the digit 0, then it would be divisible by 2 and 5. That is, the prime factorization 4 would contain 2 and 5. That is, the prime factorization will contain 2 and 5. Now if you take, लिख लेते हैं, that means prime factorization of 4 raised to power n would contain 2 and prime numbers would contain 2 prime numbers 2 and 5. Now this is not possible. We have already seen that 2 and 5 will not come in any of its prime factor. This is not possible because 4 raised power n equal to what will be 2, 4 factors of 4 will be 2 into 2 raised to power n. Contains only prime number 2, and what we are saying, in order to divisible by 10 it should contain 2 and 5, and we are getting only prime 2. So the uniqueness of fundamental theorem of arithmetic guarantees that there is no other prime factor of no other prime factor of 4 raised to power n. So there is no natural number n for which 4 raised to power n ends with the digit 0. Now you can write it in your own language also, but see here we are saying that if you take 4 raised to power n to end with digit 0, it should have 2 primes, 2 and 5. Now that means prime factor of 4 raised to power n would contain prime 2 and 5. Now this is not possible because 4 raised to power n equal to 2 into 4 factors of 4 is 2 into 2 raised to power n. It contains only prime number 2. And fundamental uniqueness of fundamental theorem says that the prime numbers does not change. The prime factors of a number does not change. That means we will not get any other prime factor except 2. And as we have seen here, we need 5 also, and we are not getting 5. So this 4 raised to power n will never end with digit 0 for any natural number n. Now in your exercise 1.2, there is a question. There are few questions. So question number first, you have to find out. You have to express each number as the product of prime factor. So this is simple. You have done it in previous classes also. That suppose I am doing second part of this one. First question. 156. You have to express 156 as the product of the prime numbers. Now, product of prime, so this can be written as 2, 7 is 14, 2 is 16, 2, 3 is 6, 2, 9 is 18, and 3, 1 is 3, 3, 3 is 9, and 13, 1 is. So what we are getting? We are getting 156 as a multiple of your product of prime 2, 2, 3, and 13. So we will write 156, 2 into 2 into 3 into 13. Here 2 occurs twice, so we can write it as square of 2. Now, in second question, you can see here, in second question he is saying that find the LCM and HCF of the following pair of integers and verify the relation LCM into HCF equal to product of the two numbers. So I am doing again second part of this 510 and 92. Now see here. Now, second question, there are two numbers 510 and 92. We have to find LCM and HCF. Now, factors of 510, prime factors. I have taken here 2 into 3 into 5 into 17. Prime factors of 92 are 2 into 2 into 23. Now, what will be the HCF of these two? 2. Here, there is only one prime factor which is common, that is 2. The HCF will be 2. Now, in case of LCM, we will take all the factors of 510 and 92 and common factor will be taken only once. Now, this LCM we are getting as this one. Now we have to verify whether LCM into HCF equal to product of numbers or not. Now first of all, LCM into HCF, LCM was 23460 and HCF was 2 and its multiple is giving us 46920. Now similarly, product of numbers were 510 and 92. If you multiply this number, we are again getting 46920. As we see from here, the product of HCF and LCM is equal to the product of the numbers. So thus, this is verified. Now, the fourth question. What is in your fourth question here? Now, in your fourth question, he is saying that HCF of 306 and 659 is given to us 9. You have to find LCM. Now, so we will use the same thing what we have done in the previous question. HCF is given to you 9. Now, as we know, LCM into HCF for two numbers. So LCM into HCF equal to product of numbers. So LCM into HCF was 9 and the numbers are 306 and 657. Now LCM will be this 9. We will divide the product by 9 and this will give us 22338. So this is your answer. Now after this, in your fifth question you will do yourself. That was same as the example I have done earlier of 4 raised to power n. This one is sixth question. Here also you can see in your in fifth question, 6 raised to power n can end with digit 0. This you have to prove. Now 6 has only two factors, 2 and 3, and as we know, for any number to end with digit 0, it should be multiple of 10 or prime factors are 2 and 5. So its prime factors should contain 2 and 5, but 6 raised to power n contains only 2 and 3 as prime. It doesn't contain 5. So it will never end with digit 0 for any natural number n. You can write it in your own language or you can refer to the example number 5 of the chapter. Now, in question number 6, what is saying? He is saying explain why this 7 into 11 into 13 plus 13 and this 7 into 6 into 5 into 4 into 3 2 into 1 plus 5 are composite numbers. Now, composite numbers, as you know, what are composite numbers? Composite numbers are the numbers which has more than 2 factors. Now see here, if you see here, yeah, composite number can be written as the product of prime numbers. Now this one was first, this one question number 6. Now 7 into 11 into 13 plus 13. Now in this 2, we are seeing that 13 is a common factor in these two. We can take 13 outside, so we are getting 7 into 11 plus 1 as we have taken 13. Now, as we see here, similarly, in second case also, in these two, we are getting 5 as common. We are taken 5 outside. Now, if we see here, we are getting at least two factor. One from here, one from here, at least one. Now, it can be composite number again, and composite number, that means it will have more than two prime factors. But if this comes to be a प्राइम नंबर, देन वी विल गेट एटलीस्ट टू प्राइम फैक्टर्स. सिंपल सी चीज है. देखो, अगर हम यहां से देखें तो एक फैक्टर 13 हो गया. कम से कम एक फैक्टर यहां से मिलेगा, प्राइम फैक्टर. वन प्राइम इज 13, अनदर प्राइम फैक्टर वी विल गेट फ्रॉम हियर. अगर यहां पे ये प्राइम नहीं है, कंपोजिट नंबर है, तो यहां पे हमें एक से ज्यादा फैक्टर मिलेंगे. लेकिन अगर हम कुछ भी हो तो कम से कम हमें दो फैक्टर मिल रहे हैं. और कोई भी नंबर जो दो प्राइम नंबर का मल्टीपल हो, वो कंपोजिट होगा, वो प्राइम हो ही नहीं सकता. तो दिस विल बी, वी आर गेटिंग एटलीस्ट टू फैक्टर्स. देयरफॉर वी कैन से these two numbers can be expressed as product of two or more than two prime numbers. या तो दो प्राइम नंबर के प्रोडक्ट होंगे या दो से ज्यादा प्राइम नंबर का प्रोडक्ट होगा. एक तो हमें पहले ही मिल चुका है, एक यहां से मिलना ही मिलना है, उससे ज्यादा भी मिल सकते हैं. तो दैट मीन्स दिस, इफ इट इज अ प्रोडक्ट ऑफ टू और मोर देन टू प्राइम नंबर्स, देन दिस विल बी अ कंपोजिट नंबर. Now, your last question, seventh question of this exercise is, he is saying there is a circular path around a field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes to drive the same. Suppose they both start at the same point at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Now, what he is saying? He is saying that Sonia takes 18 minutes to drive one round. Sonia takes 18 minutes. Now, suppose this is starting point and I am taking S for Sonia. For one round, she takes 18 minutes. Similarly, Ravi takes 12 minutes. For one round, Ravi is taking 12 minutes. Now, for second round, how much time will Sonia take? Now, she has taken 18 minutes for first round, 18 plus 18, second round 18 more, so this will be 36 minutes. Ravi will take 12 plus 12, that will be 24 minutes. 12 for first and 12 for second, 24. Now, if Sonia goes for third round, she will take 36 minutes she has taken for the first two rounds, to plus 18 more minutes, and this will be 54 minutes. Here, Ravi, he has already taken 24 minutes, to 24 plus 12 minutes more, and this is 36 minutes. Now, as we see, Sonia is covering second round in 36 minutes and Ravi is covering third round in 36 minutes. So that means after 36 minutes they will be at the starting position. Although सोनिया ने दो ही राउंड कवर किए होंगे, रवि ने 3 राउंड मान लिए होंगे, लेकिन वो दोनों स्टार्टिंग पोजीशन में होंगे. दे विल बी एट द स्टार्टिंग पोजीशन. तो व्हाट इज दिस? अब अगर इफ यू सी हियर 18, तो दीज आर 18, 36, 54 आर द मल्टीपल्स ऑफ 18. भाई 18 1 is 18, 18 2 is 36, 18 3 is 54. These are the multiples of 18. Similarly, for Ravi, 12, 24 and 36, 12, 24 and 36, these are multiples of 12. Now, if you see here, these all are multiples. And when they are meeting after 36 minutes. That means this is the common multiple. Common multiple of 18 and 12 is 36. And what type of common multiple it is? It is the least common multiple. So this will be LCM. Now after this, there will be other multiples also. After 72 minutes, they will again meet. But the out of those multiples, this 36 is the least multiple. So that means you need LCM. So what will you do? Then you can write in simple language that time taken. Now this was rough work. This you doesn't have to do in your copy. Now time taken by Ravi, by Sonia first. Sonia to complete one round. One round. That was 18 minutes. And time taken by Ravi to complete one round, and that was how much? 12 minutes. Time after which they meet again. At starting point. Will be, what will it will be? LCM will be equal to least common multiple, LCM of 12 and 18, and that we are getting, we can solve here. 12, 18, so 2 6 total, 2 9 18, 2 3 6, 3 1 3, 3 3 9, and 3 1 3. So we are getting it as 2 into 2 into 3 into 3, 3 3 9 18 36. So this, our answer is 36 minutes. So this was your, you can solve this. You have to take LCM. Now this was your exercise 1.2. What you have to do in your copy, fair copy, you have to solve the in previous video I have told you the 1.1, and before that you have to write the Euclid division lemma. Now in second 1.2, first of all you will define the fundamental theorem of arithmetic. After that you have to give the relation between LCM, HCF and the product of two numbers, and after that you will solve the exercise 1.2. Now in our next video we will proceed to the exercise 1.3. Thank you.